Hi all. Today we are going to see about a priori algorithm. So the problem we are going to solve how the candidate key can be generated using a priori algorithm. So let's see. This is a problem. So in this problem we have 9 transactions: 300, 200, 300, 400, 500, 600, 700, 800, and 900. And under each transaction, you have some list of items. So for T100, I1, I2, I5, this each is the considered to be the item. So in T100, we have I1, I2, I5. In T200, I2, I4. Likewise, till T900, we have I1, I2, I3. So these are all the different items that are found in every transactions. So now let's see how we are going to solve or how we are going to find the frequent item set. Frequent item sets using a priori algorithm, that is using candidate key generation. So this is the problem. I have copied the problem here because we need this in order to solve this problem easily in the same slide. So now first, before carrying over to the problem, now let me talk about a topic called support count. So support count, it's always necessary for the necessary to solve the a priori algorithm, because when we are scanning the databases for each and every candidate key, this these items should be equal to or greater than this support count. So in this problem, let us take the support count to be 2. Let us take the support count to be 2. I have also posted another Apriori algorithm where they have given the support count in percentages. For example, I'm giving the support in percentage, which is nothing but 50%. So what will happen in that case? How will you find the support count? So for this problem, if I'm giving the support to be 50%, then we'll take 50 divided by 100 as it is in percentage into 9. So this will be the support count. So here will come the 0.5 into 9. So that will act as the support count. So like this, we'll find the support count. Here directly we are going to fix the support count to be 2. So let's see here. First, scan D for count of each item, that is each candidate. So now let me take I1, where you have I1 1 here, 2, 3, 4, 5, 6. So this is going to be 6. I1 is 6. For I2, 1, 2, 3, 4, 5, 6, 7. So I2 is 7. And for I3, 1, 2, 3, 4, 5, 6, which is 6. And for I4, it is 1, 2, 3, 4. Sorry, I4, right? 1, 2, only 2 you have here, and for I5 you have 1 and then 2, only 2. So we have scanned a database to find the first candidate key, which is called C1. Now what happens? Now I'm comparing the candidate support count. So this is considered to be the support count. This is considered to be the support count. Now I'm comparing the candidate support count with the minimum support count. So as I told you already, 2 is my minimum support count. Okay, so I'm going to compare it. So I1 is 6, it is satisfying, it is greater than the support count. Then I2, which is also equal to or greater than the support count. And then I3, greater than support count. I4 greater than support count. I5 greater than support count. If in case if I5 is 1 instead of 2, then we will not take this into consideration, since every support count, every item support count is equal to or greater than 2, we are considering those items. Then this is called list of items. L1, from C1 we have generated the list of items which are all satisfying the support count. So now from L1 we are generating the C2 candidates from L1. So now what happens? We are generating the C2 candidate from L1. So how will you generate the C2 candidate? The combination of each and every items. Two keys or two items should be there in this candidate key C2. Now let me generate the combination I1, I2, I1, I2, and then I1, I3, which is I1, I3, and then I1, I4, which is I1, I4, and then which is I1, I5, which is I1, I5. Then I2, I3, which is I2, I3, I2, I4, which is I2, I4, then I2, I5, which is I2, I5, then I3, I4, I3, I4, then I3, I5, I3, I5, and then I4, I5, which is I4, I5. All the combinations we have made in our candidate key generation. So now what happens each and every time for each and every combination, we'll go and scan our database and then we'll find out the support count. So now I1, I2, as a combination of I1, I2, I have here and then 2 here and then 3 here, 4 here. So 4 times it had occurred. So when you come to I1, I3, so this is I1, no I1, I3, I1, I3 is 1, here 1 and then here 1 and here 1. So it is 4. And when you come to I1, I4, I1, I4, I1, I4, it is 1 here. That's all, only 1 we have. Then I1, I5. I have here I1, I5. Then I1, I5. 2 I have. And then I2, I3. I2, I3. I have 1 here. I have 1 here. I have 1 here. I2, I3. No, I have only here. Yeah, I have 1 here, 1 here, 1 here, and 1 here. So we have 4. So then I2, I4. I2, I4. We have I2, I4 1 and then 2, that's all. So I have only 2. And then I2, I5. I2, I5, I have 1 here and then 1 here, which is 2. And then I have I3, I4. I have I3, I4. We don't have any I3, I4 here, so it is 0. And then I have I3, I5. I3, I5. That's all. Only one I3, I5, so it is 1. And then I4, I5. I4, I5 if I take it. Do I have I4, I5? No, I don't have I4, I5, so 0. Now from candidate key C2, I am generating the L2 where here I'm going to compare the candidate support count with the minimum support count. Each and every candidate support count will be compared with the threshold or the support count to minimum support count. So what are all will be moved on to L2. So this is greater than 2, this is greater than 2, so I1, I2 is here, I1, I3 is here, this is not greater than 2, so I'm striking it off. And then this is greater equal to or greater than 2, which is I1, I5. So I1, I5 I have added, and then I2, I3, I2, I3 I have added, and then I2, I4 is 2, I2, I4 is added, and then I2, I5, I2, I5 is added, where this and all is less than 2, so I'm not adding. So these are all the candidate key, list of candidate key that has been generated after scanning the C2 items, that is C2 candidate key. So now till this, what is the workflow? Now I'm scanning I'm scanning the database for each candidate C1, which is a single items, and then I'll be finding the occurrences of each items. After that, the support count will be compared in the database for each and every time. For every item, it will be compared with the database, and then the L1 list of first candidate key which supports the minimum threshold will be generated as L1. Then the candidate key C2 will be generated from L1, where the C2 will be the combination of two items. So all the combinations in the L1 will be made. As I've already explained you, all the combinations with each items will be made. So that is your C2. Then what happens for each and every combinations or for each and every candidate key we have generated, we'll be scanning the database and then we'll find the occurrences of those items. So that will be the support count for each and every candidate key C2. And then after scanning and finding the support count of each and every occurrences of two items, we'll compare those candidate support count with the minimum support, and then whatever is satisfying my minimum support count will be added or moved to the list L2. Now from L2, we will be generating the candidate key C3. We'll be generating the candidate key C3. So now from this, what are all the combination we'll make it. So now let's make the combination. We'll have I1, I2, I3. This is one combination. First, let me combine this I1, I2, I3. Then let me combine this. That is I1, I2 and then I5. Now let me make this combination I1, I2, I3 which is already there. Then let me make this combination I1, I2, I4. So 1, 2 and 4 combination also I have made. Then again I1, I2, I5 which is already here. So with the first element I have combined all, and then these three sets I have got it. Then let me combine I1, I3 with I5. So what is the combination? I1, I3, I5. So I'll get 1, 3 and 5. And then I1, I2, I5. So where 1 to 5 is already there. Then I1, I2, I3 which is also already there. Then I1, I2, I4 which is already there. Then I1, I2, I5 again which is already there. So by scanning with the first and second element with all those elements, I have got I1, I2, I3, I1, I2, I5, I1, I2, I4, I1, I3, I5. Now let me combine the third element with the remaining I1, I5 with I2, I3. Now I will get four components here, four elements I1, I2, I3, I5, where we are generating only C3 here. So the combination of four elements cannot fit into C3. There should be only three combinations. So I am not taking this into account, where I have I1, I2, I3, I4, where four elements are there. Then I1, I5, I2, I4, again four elements are there. So this also I'm not taking into consideration. Then I1, I2, I5. So I1, I2, I5, just three, where I already have here. Now let me combine this element, the fourth one, with the remaining I2, I3, I2, I4. So I2, I3, I4. So it will be I2, I3, I4. So I'm getting 2, 3 and 4. So now one more is added here. Then I2, I3, I5. So I2, I3, I5. So 2, 3, 5. Again, we are getting another combination called 2, 3, 5. So we have got six combination here. 1, 2, 3, 1, 2, 5. There is I1, I2, I3, I1, I2, I5, I1, I2, I4, and then I2, I3, I5, I1, I3, I5, I2, I3, I4. Finally, only the last two pairs are left, where I2, I4, I2, I5. When I combine this, I'll get I2, I4, and then I5. So 2, 4, 5. Again, I'm getting a combination called 2, 4, 5. So this one, this combination, and then this combination, and then this combination. Totally, I have got 6, 7 combinations I have got for C3. Now again, for all these combination, I will scan the database, and then I'll find out whether the support count is high or not, or it is equal to the minimum support count. Let me check for I1, I2, I3. Let me check for I1, I2, I3. I1, I2, I3, I1, I2, I3. I have two. I have two. So this is satisfying my minimum support count. Now I1, I2, I5. So I1, I2, I5 I have here, and then I1, I2, I5 I have here. Again, it is 2, which is satisfying my minimum support. So this also I'm taking into consideration. Now I1, I2, I4. I1, I2, I4. So one I1, I2, I4 I have. That's all. Only one I have. So this is not satisfying my minimum support. So I am calling it off. I'm not taking it. And then now I have I2, I3, I5. I2, I3, I5. I2, I3, I5. I2, I3, I have 5. I have only one. Only one I have. So this will not again satisfy my minimum support count. Then I1, I3, I5. I1, I3, I5. I1, I3, I5. Only one I have. So this is also I'm not going to consider. And then I2, I3, I4. I2, I3, I2, I3, I2, I3, I4. Not even 1. It is 0. I2, I3, I4 is 0. So I am calling it off. I'm not taking it. Then I2, I4, I5. I2, I4, I2, I4, I5. No, not even 1. So the remaining all 5 are taken off as they are not having a minimum support count even. So only I1, I2, I3, I1, I2, I5 are actually satisfying the minimum support count. So after scanning, I'm having 2 for this. Fine. So now what happens? I am taking these as the final L3, that is from C2, whichever is satisfying the minimum support count. Now, these two patterns, these two item sets are considered to be the frequent patterns generated or frequent pattern item set that has been generated from this transaction through a priori algorithm. Hope everybody understood this. In the next slide, we'll see how strong association rules will be generated for the frequent item set that has been found through a priori algorithm. We'll see that in the next video. Thank you.